Hello everyone, this is Alan with the problem about torque, problem number 6. So the problem reads, a uniform plank of length 5.0 meters and weight 225 newtons rests horizontally on two supports, with 1.1 meters of the plank hanging over the right support. See drawing. To what distance x can a person who weighs 450 newtons walk on the overhanging part of the plank before it just begins to tip? So because it's before it just begins to tip, you know that this right here must be the center of mass, or the center of torque. So you need to know the torque of this entire board, and you need to know the torque on this person. So this board has a weight of 225 newtons. It's evenly dispersed, a uniform plank, so you know it is located right here, the center of mass. So it actually is pulling down right here. So this is 5 meters, so half of it would be 2.5. The other half would also be 2.5, this whole length here. This is 1.1 meters, so this you just subtract, you get 1.4 meters. On this side, the distance is unknown, the x, and the weight is 450 newtons. That's a 4. Just trust me, it is. So, the torque on both sides of this pivot has to be the same. For the board, it's 2, and the equation is torque equals the perpendicular radius, perpendicular to the force, times the force. So for the board, that would be the distance 1.4 meters times the force, 225 newtons. Put that into a calculator. 1.4 times 225 equals 315. So the torque on the board is 315 newtons per meter. Now for the person. Well, the distance is unknown x, and the force is 450 newtons. But this torque equals this torque for it to be just about to tip at the pivot right here. So that equals 315 newtons per meter. So to do that, divide both sides by 450 newtons. Put that into a calculator. And you get 0.7. So the distance that the person can walk out is 0.7 meters. And you now have your answer.